Attendees view. Attendees view. Very good morning to all of you. My name is Kapil and I welcome you all to this webinar on RC design as per ACI 318 and BIM in MIDAS Gen. So on your screens, we have the flow of today's presentation. First of all, I'll start with a short introduction on MIDAS Gen. Then we will know about RC design in MIDAS Gen in detail. We will know about RC frame as well as slab design in MIDAS Gen. Then we will go through some special provisions for seismic safety. After that, we will discuss about General Section Designer, which is a special tool in MIDAS Gen for irregular sections. And then finally, we will be talking about BIM capabilities of MIDAS Gen. And then we will have the question answer session. As some of you may be new to MIDAS Gen, so first of all, I will like to introduce you regarding the software. MIDAS Gen is a 3D FEM software for structure analysis as well as design. On your screens, you have the four major functionalities of MIDAS Gen. So the first is the seismic specific functionality. Second is the comprehensive design. MIDAS Gen supports a large number of codes for design. Then we have the high-res specific functionality. You can incorporate the effect of time-dependent material properties. We will be having a different webinar for studying the high-res specific functionality. Finally, the intuitive user interface of MIDAS Gen is very special. People find it very easy. People find it very easy to learn the software and adapt to the software. So this slide summarizes the all-in-one modeling analysis and design capabilities of MIDAS Gen. So the first is the modeling part. We have the various structure wizards for easy modeling. Then interaction with the BIM tools like Revit structures and Tekla structures. Then we have the CAD interface. The CAD interface is supported by the error detection feature. So it helps in reducing the number of errors for the model which is imported from AutoCAD. And then we have special features like the shear wall element, which help in the modeling and design of buildings. Then for analysis, MIDAS Gen supports high-end analysis also. The static analysis, plastic analysis, second order analysis, eigenvalue analysis, buckling analysis, and then the outputs are available in the form of forces, stresses, tables, graphs, and for buildings, the results are available in the story tables. Then for coming to design, the software supports the design of RC as well as steel. SRC design is also supported. So then the output for design is available in the form of graphic reports, detailed reports, and the general section check is also supported. Now, the interface of MIDAS Gen is optimized for buildings, but the software supports the design of structures other than the buildings also. So you can see on the screens that the software supports the design and modeling of stadiums, power plants, hangar, airport. That's why it is a general structure tool, and it is known as the one-stop solution for analysis as well as design. Now let's move to the software. Yeah. So this is the interface of MIDAS. So we will see some of the modeling features. Here we have the structure wizards in the software. For buildings, we have a frame wizard, which is very useful. So let's say we want to have a 3x4 bay structure with 6-meter span in one direction and 8-meter span in another direction. So we have added this information, and then we generate the frame, and then we select the materials and the section properties, and then we'll go to the point where we want to insert the frame, and now we need to select the plane in which we should enter this frame. So we want to enter this frame in the XY plane. So I'll put the alpha angle as -90. So you see how easily we have generated the frame. Now I want to create the first story from this frame. So I'll just go to model, elements, and extrude. Or else I can also access this option from here. I have the extrude option, and I'll select the material as well as the section for the columns, and then extrude the columns. Now I have the first story with me. I need to generate the structure from this. So I'll go to model, building, building generation. So the first story is of height 3 meters, and above this I want my one story to be of 3 meters. Next 3 stories of height 2.8 meters, and above it I need 3 stories of height 2.75 meters. So I'll add the information and then click. So how easily I have generated the structure. Now I need to assign boundary conditions. So I'll select the plane at z is equal to 0. It gives me the selection for all the nodes, and then go to boundaries, supports, and select the desired properties. So I have the structure ready with me. Now I want to generate the loads. So first is the self load, self weight. Second is the wind in X direction. Now to generate the self weight, I have a very easy option. I need to select the load case and the direction of the gravity. Doing this, the software will automatically apply the self weight to the structure. And now if I want to apply the wind load to the structure, I'll go to the load, lateral loads, and wind loads. Here I can auto generate the wind load for various codes. So I select the international building code and then input the various parameters, and then I need to input the direction factor. I want to generate the wind load for the X direction, so I'll make the direction factor as 1 for the X direction and 0 for the Y direction, and click on OK. Now also I need to generate the story information. So here you see that the software has automatically detected the stories for the structure. Now if I go to load, lateral loads, and I check the wind load profile, then the software will tell me the story shear force, the story shear, and the overturning moment. It can be exported to Word format. So in this way, the software can easily generate the loads. Also for static seismic loads, the same way we generated the wind loads. Now, we will talk of design functions in MIDAS. So the soft today we will talk about the concrete design features only. First, we'll discuss about the concrete code design, then about the concrete code check. The difference between design and check is that when we perform concrete code design, the software will recommend us rebars as recommended by the code. But if we want to perform the check, then we will specify some rebar information for the sections, and then the program will tell us that if that section is appropriate or not. After that, we will discuss about the ductile detailing, and then slab design in MIDAS. The software also supports the footing design as per ACI code. So these are the available codes for design in MIDAS. For RC design, we have American codes, Euro codes, British codes, Indian codes, Canadian codes, and other country codes. For steel design, we have American codes, Euro codes, Canadian codes, and other country codes. For SRC design, at the moment, we have these codes in MIDAS. The footing design is supported as per American codes as well as the British codes. The slab design is supported as per Eurocode 2 and ACI 318 in the software. We are in a process of constantly updating these codes. Also, MIDAS interacts with a different tool which is known as Design Plus, and it is a component design tool. So we can design footing, basement walls, corbel and brackets, beam tables, stairs, and batch walls using Design Plus. Now, this is the ACI code implementation status. The material code is incorporated into the software database, and we have all the concrete as well as steel materials as per ASTM. Then we have the section database as per AISC. Then we have the auto generation of the loads for static wind load, static seismic load, and response spectrum function. For design, the software supports the auto generation of load combinations as per ACI 318 and AISC LRFD. For concrete design, we have ACI 318. For steel design, we have AISC LRFD. And for slab design, the software supports ACI 318. Now let's talk about the RC frame and wall design in MIDAS. So whenever we start to design a frame, we need to specify that if the frame is a based or an unbased frame. So this can be done very easily. Just go to design menu and definition of frame. Here we can select that our frame is unbraced or based in X direction and Y direction. Also, the software supports the auto calculation of the effective length factors. So if we want the software to calculate the effective lengths automatically, we just need to check on this option. Otherwise, we can have a manual input of the effective lengths. Then we have a member assignment tool in the software, which is a very useful tool. Let's see how is it useful. So let's say I want to design this structure, and here I have two beams. One this and one this. To incorporate this beam, I have to divide this member in two parts. But physically, this is my one girder. So what the software will offer me is that option called member assignment option. Here, what the software can do is that the software can detect that what members are to be considered as one in the design. So what I need to do is that select the option, go to add replace, check on automatic if you want the software to automatically produce some suggestions for you, and then all. Clicking on apply, you see that the software has automatically detected the members that they should be designed as one. Then we have the options for selecting the design section. We have two options. First is the beam and offset, and second is the panel zone effect. Let's see where they're useful. Now, when I want to design this structure, then the member forces will be calculated at this section. But this is a rigid zone, and I want to reduce the design bending moments to this section. So what do I have with me is that I can go to model, boundaries, and the beam and offsets. Here I can directly enter the value of the beam and offsets. I can enter the distance of the nodes of the section and my desired design section. So this can be done using this if you want to go for manual input. Otherwise, I have one more option called panel zone effect. Now, if you go to auto calculate panel zone offset distances, then the software will automatically calculate the design movements at this section and will not include the movements of the rigid zone. Then these are the RC sections available for design in Gen. If you want to design a beam, then you can design a rectangular beam or a flanged beam. For columns, the software supports the design of rectangular columns, circular columns, hollow circular columns. The software supports both the spirally reinforced as well as the tied columns, and the rectangular walls are available for design. Now, the software supports the auto generation of the load combinations. In the results menu, we have the auto load generation. So in the load combinations dialog box, we have various menus. The load combinations under the steel design will be used for steel design, and under the concrete design will be used for concrete design. So what I need to do is that go to auto generation and then select the applicable code. So I select the ACI 31811, and the software also offers me to generate the load combinations to consider the orthogonal effect. This is for seismic cases. If your earthquake is in X direction and you also want to consider the effect of the Y direction, then this option is used. Also, you can have the load combinations in the Excel form. So it is very easy to edit the load combinations in this form. Then the software supports the manual as well as the update by code for strength reduction factors. So here we have first the selection of the design code. So you can select that according to which code you want to design your frame. And after that, we have the strength reduction factors. You can simply update by code, or you can input your own desired parameter also. Then we have the modify concrete material. Whenever we select for material for the analysis, we need not select the reinforcement properties. So in this dialog box, we can specify the reinforcement properties, the rebar code, and the material. Then the software supports both design as well as checking. The difference between design and checking is that whenever we perform design, the software suggests us the required reinforcement based on the code. But if you want to have some user input of the rebar, and then you need to know if that rebar is appropriate for the section or not, then that process is known as checking. So in checking, you can specify your own rebar and perform the strength verification with the updated rebars. Then the beam design. So you can control the beam section, the cover, the bar size. You select that what rebars you want to input to the section, and the most appropriate rebars will be selected through that. And then the number of legs for transverse or shear reinforcement. Then the code will automatically take care of the minimum rebar ratio, minimum spacing for bars, and the maximum stirrup spacing. The software supports both singly as well as doubly reinforced beam sections. This is the algorithm as specified by ACI for beam design. Then this is for column design. You can control the section size, cover to rebar, the bar size, and the software will automatically take care of the maximum rebar ratio, minimum rebar ratio, minimum spacing for bars, and the maximum stirrup spacing. Then this is for the column design. So the results of the column design are based on maximum axial forces and the biaxial moments that are evaluated on the basis of the PM interaction diagrams. Then this is the detailed algorithm for the column design. So depending upon your frame is a sway frame or your frame is a non-sway frame, the software checks if there is a need for moment magnification or not. So if the slenderness ratio is less than the desired limits, then the software doesn't magnify the movements. It ignores the slenderness effect. If it lies between some specific limits, then the software applies the movement magnifier method. And if it is greater than 100, then you can perform the P delta analysis. So if you want to magnify the movements for column design, then that can be done in two ways. Either you can go for second order analysis in the software, or you can just skip the second order analysis and ask the program to magnify the movements depending upon the code. This is for the shear force design. So the program calculates the shear strength of the concrete, the shear strength of the reinforcement, and then the minimum shear reinforcement required. Let's see the software now. So I have the structure. I'll perform concrete code design. As I have selected the entire frame to be designed at once, I can even select some specific members to be designed in one attempt. So here you can see the state of the member design. So we have the results with me. Uh, so here you can see that the results can be sorted as per member or as per property. So we'll see that what is the difference between them. Actually, when modeling the structure, we have same section sizes for some members. So that is known as the group by property. So if I select some group and click on update the rebar, then the same reinforcement will be provided in all the members of that section size. But if I go to member and then click on update rebar, then that reinforcement will be provided to only one specific member, not to all the members of the same section size. So here we have the design reports with us. First is the graphic report. It is a summary report. In summary, you have the material data and the section properties, and then you have the section diagrams. After that, we have the bending moment capacity as well as the desired bending moment for the section, and then the ratios. Then also I have the information regarding shear capacity. Also we have a detailed report for design. In the detailed report, the software first gives us the information about the load combinations. Then we have the information regarding the section size and the material information. Then we have the reinforcement pattern. Then we can have the detailed calculation of the positive bending moment capacity, followed by the ratio of the desired and the capacity, and then the same for the negative bending moment, and then for the shear capacity. Then if we look for the results of column design, then we have the PM interaction curve with us. So here in the graphic report, the software tells us about the PM interaction curve for the column. So these are the various result outputs that we just discussed. Now, let's say I design a certain member and I found that even after specifying the maximum reinforcement for this member is not able to resist the desired forces. So what would be the first thought coming to your mind? You go to pre-processing mode, change the section size, perform analysis, and then design and see if the new section size is enough or not. And if it is not enough, then you go back again to the pre-processing mode. But it wastes a lot of time. So what the software offers to me is that option called section for design. So here I have the sections that will be used for design. So here I can just modify the section data to be used for design. I just make changes to it. So now I perform the design for a specific member. So here you see we have the revised dimensions. now the entire report is as per section dimensions of 500 mm by 600 mm. Then we can also perform the check in the software. For that, we have the modify beam rebar data. Here you can specify that what rebar you want to use for a member. So let's say we make some changes here, and then we can see the detailed figure, and then that section will be used for the design. So this is the section for design we just discussed. Now let's see the meshed slab and wall design in MIDAS. So the software supports the slab flexural design, slab flexural check, slab serviceability check, punching shear check, and wall design. If you perform slab design, then you need to input the subdomain data in the software. Let's see, where is the subdomain useful? On your screens, you can see that you have a slab of irregular shape, and the reinforcement in the different parts of the slab will be in different directions. So here what the software offers you is that you can specify a subdomain for a part, and then you can specify the direction of reinforcement. Like for this subdomain, you can specify that in what direction you want the reinforcement. So here you are specifying that you want the main reinforcement to be at 45 degrees from the global X direction, and then you can specify the direction of the second direction. So we have a model with us. Let's activate a typical story for this. So I have the typical slab with me, which is irregularly shaped. Now, if you perform slab flexural design, then the software supports the output as rebar spacing and diameter, required rebar area, required rebar ratio, that is the ratio of area of reinforcement to the section, then the resistance ratio, and the wood armor moment. The software designs the slab as per the wood armor moment, as this method is more fundamental for irregular shaped slabs. So this is used to transform the torsional moments into MXX and MYY. So let's design the slab. So in the design options, we have meshed slab and wall design. So the first one is the slab wall load combinations. So the reason that we have provided this option is that sometimes the engineer wants to design the slab only for the vertical loads. They do not want to design the slab for the lateral loads. So here you can make a selection that for which load cases, load combinations you want to design the slab. So the slab design will be performed only for them. And then you can choose the design criteria for rebars. So here we have an option of selecting the basic rebar for slab. If we check on this option, the basic rebar for slab, then the software will provide the same reinforcement throughout the slab, and where necessary, the software will provide the additional reinforcement. and then you can select that what rebars you want to use in the slab, what are the available rebars, and the allowed spacing. Then you can also specify the serviceability parameters, that what should be the limiting deflection, and then the deflection amplification factor. Now, when we perform seismic design, then we perform the seismic design for the reduced force, and we assume that the difference between the reduced force and the actual force will be taken care by the plastic behavior of the material. But the deformations in the structure will be for the actual seismic load, not for the reduced seismic force. So in order to see the actual deflections, we need to amplify the deflections, and here we can use the deflection amplification factor to amplify the deflections. Now, let's perform the flexural design for the slab. So first, let's see the wood armor moment. Similarly, like frame design, if I select a part of the slab, only that part of the slab will be designed. So here we have the results for the wood armor movements in the form of contours and also the legend. Then we can have the design forces in the form of table, that for which element of slab, which load combination is most critical, and what are the movements for that load combination. The results can be easily exported to Microsoft Excel. And then the resistance ratio. So we will get the contours for the resistance ratio. So here we have the contours. And also the software will provide us with a detailed design report. The detailed design report will be containing the step-by-step calculation of the slab capacity, the desired strength, and the ratios. So here you see we have the critical element number, the critical load combination, material information, thickness, and covering. And then we have the calculation of the strength and then the ratio. Similarly, we have this for bottom as well as top of the slab. Then we have the slab shear checking supported by the software. So the shear checking is supported using stresses as well as the forces. Using the forces, the software use the formula from the code to perform the punching shear check. And for stresses, the software obtains the results from FEM analysis. We have seen the slab serviceability check. Now let's see the punching shear check in software. So the software will detect that where are the columns located for the slab and will give us the critical parameters as well as the ratio of the strength and the capacity at those critical parameters. Also, a detailed design report will be created for the punching shear checks. So here we have the results with us. So like this is the critical perimeter, and then if I select the elements, then I can have the design report for this. So here the specifying that this is the capacity, the shear capacity, and this is the desired capacity, and this is the ratio. So we have the punching shear check results as well as the design detailed report. Now let's see about the wall design. So the software supports the wall design as per ACI 318, and the software will give us the results for the horizontal as well as the vertical reinforcements, and also you can check the concrete stresses. Let's activate some part of the walls and perform the wall design for this. So here we have the wall design results with us. We have the resistance ratio check, and then we have the design forces, and then we can have the results for required reinforcement. Now let's talk about the special provisions for seismic safety. Whenever we design for a frame, then we need to ensure that the column failure is preceded by the beam failure. So we need to have strong column weak beam design. For that, we need to get the column shear forces, and this is how the software magnifies the moment for column design. And then the same we have for the beam design. Now let's talk about General Section Designer, which is an additional tool in MIDAS Gen for irregular sections. Now let's say we have a column and we want to design this column for a irregular shape. So what we have is that we go to Tools and the General Section Designer, and in General Section Designer I can specify the shape. The shape can be basic or a general shape. So here I'll enter the coordinates of my shape. So also I'll select a material. I can specify the nonlinear properties for the material. So I have the irregular material with me, irregular section with me. So I can link both the softwares and then export the shape to Gen. So here I have added section property with me. So I'll just assign this property to the column by simply drag and drop. And here you can see that we have the revised section with us. In the properties, we have the section properties. Now, let's say we perform the analysis for this change section, and then we can import this section in GSD. So here the software gives me an option to select the load combinations for which we want to import the results. So here is the section. And the information from the load combinations. Then we will specify the reinforcement for this. So to specify the reinforcement, first we need to have rebar material. So I can choose any rebar material. So also I can specify the rebar for this. Then after it, I can get the reports for the moment curvature curve, the stresses, and also GSD supports the import of sections from AutoCAD. You can import the DXF files directly into GSD. This is the link between Gen and GSD that we just discussed. Now let's talk about the BIM capabilities of MIDAS Gen. So the software is capable of interacting with Revit as well as Tekla structures. Today we will talk about Revit structures. Let's say we have a model in Revit structures composing of beams, columns, and slabs. So here let's check the properties of all the three elements. I have a beam with dimensions 300 by 600 mm, and the column has dimensions 400 by 400 mm. So as we install the interface between MIDAS Gen and Revit structures, then in Revit structures under external tools, we can get an option send model to MIDAS Gen. So here we can control the mesh size for the plate, and then we can control the input units and just click on send. And then the software will report me that sending Revit model to MIDAS Gen has been done. Now I shift to MIDAS Gen. I open a new file and I import the MGT file created by the interface. So here you see we have the model that was in Revit, we have imported it successfully to MIDAS. Now let's change some properties. For the section, I create this is a section for column, and I create new properties for it. I make it 350 by 500 mm. And then for beam, I change the properties. I make it by 500 by 500 mm. And then for slab, I change the thickness to 250 mm. Now I'll just import this model in Revit structures. So we need to replace the original MGT file. We have the new MGT file with us. I'll go back to Revit and I'll ask the software to update model from MIDAS. So as soon as I click on update, the software will give me a summary for the update, that what elements are updated, what properties are updated. So here I have that one thickness is changed and two sections are changed. Now let's see the new properties. So here I have the new properties. The old was 300 by 600 mm and the new one are 500 by 500 mm, which have been successfully updated from MIDAS. For column also I have the new properties, 350 by 500 mm. Originally it was 400 by 400 mm. And for slab, we change the thickness from 300 to 250. So we have the thickness updated as well. So the two-way interface supports the transfer of section information, deletion of elements, the change of location of elements, addition of some new elements, the change of configuration of the elements and the material properties. And this is the information for the Revit and MIDAS link interface, which will be releasing in May. So these properties are applicable at the moment also, and we will be introducing the boundary information exchange, the load information exchange, and the load combination information exchange. So this will make the interface more flexible and more adaptive to the requirements. So this was all regarding the today's presentation. If you have any question, then please feel free to ask in the questions window. If you have any questions, then please feel free to write in the questions window. So we have some questions. So the first question is that, what does MIDAS offer for the boundary conditions for the buildings with the basements? So here we see that we have a structure and we have the basement in the structure. So we can have the various boundary conditions. we can have the point spring supports, and we can have the elastic links. So in boundaries, the software has the general spring supports and elastic links, which can be used for basements. And then I hope this clarifies the available boundary conditions. If you need more information, then please let me know. Then the second question is that what is the difference in results of reinforced concrete structure by using automatic assignment of rigid floor diagram or modeling slab with the plane stress approach? So you have seen the models using both approaches, but which one is more accurate? So the difference between both of them is that if you model the floor, then there may be deformations, in plane deformations in the floor. But if you use the rigid floor diaphragm, then all the mass of the floor is located at one point, and there are no in plane deformations in the slab. If you need, I hope this clarifies, but if you feel some more information should be added, then please let me know through the questions window. Uh, then we have that interaction of Uh, we have a question that where you can find the additional videos or tutorials on RC design. So for this, I would like to tell you that you can contact us anytime if you need some more help or support on the design. You can write us to at yjkim@midasit.com. I will spell again yjkim at midasit.com, or else you can also visit our website midasuser.com, midasuser.com. So we have a question regarding the modeling of slabs or without modeling of slabs, which approach is more accurate considering the rigid floor diaphragm. So I would like to tell you that for regular shaped buildings, this doesn't make a big difference, but for irregular shaped buildings, modeling the slab is recommended. So next question is for the supports in the model that I'm just showing. So on the screens you can see that we have the supports displayed, and here we have the supports for the grounds. So all the three surfaces interacting with the ground, we have modeled them using point spring supports. Next question we have is that how can you model the curved beams and curvilinear structures? So on this I will recommend that in model and structure wizards we have an option to model the arches. So using this you can model the curvilinear elements, but the software doesn't support the curvilinear elements. The curve has to be broken into straight beam elements to model. So here we have the arch wizard. So you can select the various shapes and then model it very easily. The next question is that if we have the sidewall supports in this model, so in this model we do not have the sidewall supports. So having the sidewall supports depends totally on the engineer's judgment. You can model the sidewall supports using the various options available. So in this model, we are not considering the soil structure interaction. So if you, and for the sidewalls, so if you want to model the supports, then you can do it using the various options available. As this can overestimate the deformations of the building, so the stiffness of the supports also need to be inputted by the engineer. Here in the properties, we have the option to input the stiffness. So we can have the point spring supports. Next is regarding the T-beam analysis for beams. So in Gen, we can model the T-beams and then we can have the RC design for the beams. So here we have the T sections and the user can manually input the dimensions of the section and then model the section, and further it can be used for analysis as well as design part also. So if you have any questions, then please feel free to write in the questions window. So the next is regarding that there is a meshing in the core walls in the model and there is no meshing on these side walls. So this is for the modeling convenience, and so in this model the basic behavior for the wall elements and the modeling as a plate will not make much difference. So for the modeling convenience we have not meshed the side walls. I think there are no more questions now. So in future you have any questions, please feel free to write us back at yjkim@midasit.com. So thank you for attending today's webinar. I hope it was useful.